You after something, Warren? You good?
I'll catch you later.
Oh, you're going to run away because I said I was recording.
Relay boxes for tomorrow on what?
Yeah.
Relay boxes.
Okay, so we'll start then with total resistance. We got a series circuit here. How am I going to work out my total resistance? Add them all together. So in a series circuit, total resistance is just adding together each of the individual resistances, right? I'm gonna whiz through this pretty fast. So if you have questions as we go, sing out. Otherwise, I'll just assume that everybody knows what I'm talking about. So R1 plus R2 plus R3 is going to equal 20 ohms. Everyone agree with that? Cool. So, 30 ohms. Thank you. So then I want to work out my total current. How do we work out current? It's a formula. V over R. Right, so I've got 89 volts, that's my V. And I divide that by my total resistance, yeah? That will equal
2.96.
Yep, pretty bloody close to 3. 2.96 amps. Cool. All right, so the next thing is volt drops. My volt drops in each of the resistors. How am I going to determine what is the volt drop across each one of those? What's the formula for voltage? Current times resistance. V equals IR. So because I know in a series circuit, my total current will be the same. Well, my total current will go through the entire circuit, right? So my current for each of those resistors will be the same as the total current. So if the question asked you what's the current in R2, and you have a circuit like this, it's going to be the same as the total current. Everyone's cool with that? So for this one, if I want to work out the individual volt drops, I use the same number for current in all of those formulas. So the volt drop on R1 will be current 2.96 times the resistance of that resistor, 8 ohms. So that should equal something like 23.68. 23.68 volts. Voltage in R2, do the same formula, 2.96 times the resistance of R2, which is 10. So that'll be 29.6 volts. And the voltage in R3 is going to be 2.96 times 12, which will equal You volunteered, you were my calculator man. What was it? 35.52. Okay.
You said 35, but you're at 36.
Shit. Alright, my brain is not here today, is it? 35.52. So we can check that. We can check that by adding those 3 volt drops together, and those 3 volt drops in that series circuit should equal what? Total current. So 23 plus 29 plus 35. Total voltage. Jesus. Maybe we should just scrap this. Kirchhoff's law is volt drops in a series circuit should equal the total voltage. Somebody quickly add that up for me while I find All right, so if I add those three together, what's the answer? Anyone? Is it 89 exactly? What is it? Well, if it's something other than 89, then I have to go back and recheck my calculations, right? Because something's not right. 88 point something? Okay, that's close enough. 88 point something with a small margin of error for rounding. Just so you know, when you get these questions in the test, they're always going to include, I think it's 5% margin of error. So as long as you're within 5%, that's just to account for the fact that there will be some cumulative rounding effects, yeah? 88.79. Yeah, so pretty close. Okay, so we've got our total resistance, got our total current, we've got our volt drops. So now we want to work out the power in each of those resistors. So what's our best formula for power in this particular situation? We could go 2.96, 23.68. I squared R, did you say? Yeah, we can use I squared R. Well, actually, for this one, it's pretty simple. Our simplest formula for power is always going to be I times V, right? I times V. So if I know what the current is and I know what the individual volt drops are, then I might as well use that one. If I just ask you to find the total current and then the power in each resistor, you might use I squared R, right? Because we know the resistance of each resistor and we know what the current is. And that way we just don't have to go through that extra step of finding the voltage. All I squared R does is it embeds the formula for finding that volt drop into the formula for power. So I just don't have to do it. Does that make sense? Yeah. Oh, we could just use V times I, right? So again, we can use the same current. So power in R1 will equal 2.9. I did it again. 2.96 amps times 23.68 volts. Which will equal 70.09. 70.09 watts. Again, just a little tip for the test. When you get these power questions, there's actually a few of these type of questions, just pay attention to what the units it's asking for. If it doesn't ask for the units, just put it in watts. If it says kilowatts, then we have to put it in kilowatts, right? Not that I would ask for kilowatts to a question that has an answer of 70 watts, but if I did, what would the answer be? 0.07 kilowatts. We all got that, right? So a kilowatt is 1,000 watts. So if you work this out and it was 1,500 watts, but in the question said give your answer in kilowatts, you write 1.5. Yeah. Actually, I think the only question that I remember in this unit where that was an issue, and it was an issue for quite a few people, was which one was it? Number of cycles per second, or the period of a cycle. So that question actually said give your answer in milliseconds. Yeah. If you just use the formula, it's going to give you an answer in seconds, right? So you need to convert that to milliseconds because the question says give the answer in milliseconds. So, so I sat there that afternoon when we had that test, and I just copied the answer is in milliseconds, and then every time one of you texts me, I just pasted that same text message and sent it back. Okay, so power in R2, we'll do the same thing, 2.96 times the voltage drop across that one, 29.6. $87.62. And power in R3 will be 2.96 times 35.52. $105.14. And then actually most of these questions are going to ask you then for total power. What's the easiest way for me to work out total power? Add them up. Or total voltage. Total voltage times current, total current, right. So you can just use the V times I again. Because I want total power, I'm going to use the total voltage and total current. So it should be 89 times 2.96. Should be 263.44. And I'll check that by adding them together. So I can take my previous one, 70.09 plus 87.62 plus 105.14. $262.85. And once again, that is well within my margin of error. Cool. Okay, is everyone okay with that? So that's how to work out. There's nothing else we need there, right? So that's all of our volt drop, the total current, total resistance, all of our volt drops, and power on each of those resistors in a series circuit. Happy? Yeah. Obviously, we didn't work out the current in each of the individual ones because it's all the same through the circuit. Okay. So let's have a look at a parallel circuit. Okay, So we've got a parallel circuit with two resistors. I've got 144 volts, 20 ohms on R1, 33 ohms in R2. And we're going to find total resistance, total current, current in R1, current in R2, power in R1, power in R2. I have not asked you, or we're not going to find volt drop across each resistor. Why not? Be the same. So the voltage on each of those resistors is going to be the 144. Yep. So how am I going to find my total resistance? Use the parallel resistance formula. Yeah, I wish it was that easy every time. How will I find power? Oh, I use the formula for power. Okay, I know what you mean though. So we'll go. So that's going to be R1 to the -1 plus R2 to the -1, and then the resultant of that to the -1. Yeah. So be this 20 to the -1 plus 33 to the -1 bracket -1. Agree? It gives me 12.45 ohms. Anybody else do that? Just one person to confirm my answer. You got the same? Good enough for me. And then I need to find total current. So how will I work out the total current?
V over R.
V over R. So I'm going to use total voltage divided by total resistance.
$11.56.
11.56. 11.56 amps. Okay. Everyone okay with that? So now I need to find out the individual currents in each of those things. How will I do that? That's easy, right? Because total current will just be the same down each resistor, right? Yep, so it's 11.56 amps in each resistor. Cool? Different. Yeah. This is different. Raymond's shaking his head. Devesh is agreeing with me. What does everyone else think? No opinion. Oh, come on. If you can't even spot an obvious fake, seriously. So it won't be the same in every resistor. It's going to split, right? Our current is going to split between the two. So what formula should I use to find out the individual currents in each of those legs?
Yeah.
V over R. I equals V over R. Same as we've got here. So I in R1 will be 144. 144 because the same voltage on the supply is going to be present on each resistor. So 144 divided by the value of that resistor there, right? Somebody work that one out. And then I in R2 will be 144 over 33. Uh,
7.2.
7.2. Should have worked that out.
Yeah. Weak.
So I've got 7.2 amps here. and 4.36 amps there. And then we already worked out our total current here is 11.56. So what's the relationship between total current and the current in each of the legs of our parallel circuit? Right, so if I add those two together, it should equal that, right? Which it does exactly. 7.2 plus 4.36 is 11.56. Sweet. Happy with that one? Okay, so let's have a look at power actually. Yeah, again, we're not going to bother with volt drops because there is no volt drop. Each of those will have 144. So now I want power in R1, power in R2. How should I work out power for this one? V into R. No. Multiply. V times I. Same as before, right? V times I. Again, in a parallel circuit, you might use V squared over R. Because if I just have the voltage and the resistance, then I can go V squared divided by R. That's my power, right? But we've already worked out the current, so we might as well use it. Again, if the question didn't ask you to work out the current, if it just gave you those three values there and it said work out the power, I don't even need to worry about the current. I'll just go V squared divided by R. Easy. We'll use V times I because it's easier. So it'll be 144 times 7.2. And for the second one, 144 times 33. So yeah, 1036.8 watts here and 627.83 watts there. If I add them together, then my total power will be 1664.6. Which I should be able to confirm by doing what? I just added them. Multiply what? Total current and total voltage. So I got 144 times 11.56, and that equals 1664.64. Perfect. Easy. Happy with that one? Good. Okay. Okay, so we'll do a series parallel one. I think this is the one where most people have had trouble, right? in particular finding voltage and power across R2 and R3. I think that's been the actually by far the most common error across all of the maths tests that we've done. Voltage and power on R2 and R3. So we do the same thing. We're going to look at volts in every resistor, current in every resistor, total voltage, total current, power on each of the resistors, and then total power. So let's start with total resistance. How am I going to work out total resistance? Yep. So I'm going to use the formula for parallel resistance first. So it's going to be 20 to the negative 1 plus 30 to the negative 1 to the negative 1. And then I add the value of my series resistor. Yes? Agree? So this part of the formula here is going to give me the resistance of those two parallel resistors. So we're going to work that, let's work that out first because we'll need that later. We'll need to know what is the resistance of those two in parallel. Because another way to think of this would be that's one resistor in series with this one here. And when we start to work out our volt drops, that we need to know that, right? We need to know what that, if you think of it, what that series resistor is. Okay, so if I use that parallel formula, got 22, exactly 22. Anyone else? You got it? So it's going to be 22 plus 10. We'll just note that over there, 22. Oh, I said, so it's 12 for the parallel part. Okay. Oh, that makes it couldn't be 22. Couldn't be 22, I should see that straight away. Why? Because the total resistance of a parallel circuit must be less than the lowest one. Yeah. It's got to be less than the lowest one. Why? Because if that's 20 ohms, then adding any resistor in parallel to that, even if it's 1,000,000 ohms, provides one alternative, at least one alternative path of current, right? So then the total resistance must be less. If that's 20, then adding any more resistors on that is going to give a less resistance or more current, if you like. Oh, you piece. Okay. So that gives me 22 ohms. This is my total resistance here. So then if I want total current, what's my total current going to be? Voltage. Voltage divided by resistance, right? So this is an easy one. 100 divided by 22. 4.55. All right, so what's next? If we're working on current, no, let's go to voltage first. Okay, so this is one where people have struggled. If I say, what is the volt drop across each of those resistors? Where should we start?
By giving the voltage in your parallel.
Voltage across the parallel?
Like the total. Are you doing a volt drop?
Yeah. Well, let's start with the voltage across R1 because we know what our total current is. So the total current will be the same as the current through that resistor. Yeah. Now the current through those two is going to be different, but so we'll leave that for now. So voltage across R1 must be I times R. Then I use my total current, which is here,
Times 10.
4.55 times the resistance there, 10 ohms. So it'll be 45.5 volts. 45.5 volts across there. Okay, now I'm going to work out my voltage across R2. How will I do that?
By using your voltage times the total resistance.
Yes. So the proper way to do it would be using current. Did you say voltage or current?
The voltage times the resistance total of your parallel.
So it'll be current. You got it right, but yes, current. So my total current times the resistance of that parallel circuit. Now that total current is going to divide between those two. But in terms of working out my volt drop, remember there will only be one volt drop. It's going to be the same. So I use my total current because that's going to be the current across those, or current through those two will add together to be the total current, right? So the correct way to do it, so we're going to do V, R2, R3, because it'll be the same voltage. Everyone understands that, eh? It's not going to be the total voltage, but the voltage across those two will be the same as each other. So I would go total current, which is 4.55, times the total resistance of those two, which was 12 ohms, which equals 54.6.
Can you just take the total volts?
Yeah.
That would be easy.
Yeah, so the easy way, the cheats way if you like, would be once I've figured out the voltage there, I can just go 100 minus 45.5. So if I did 100 minus 45.5, that should give me 54.5, right? Which is pretty close. I worked out 54.6. But if I just do the subtraction, I get 55.5. So more or less the same thing, right?
So what? How do you get the total voltage? You just add R1 and then add-
Total voltage is given.
Yeah, but like, so do you add 1 and then 2 and 3 together to get the total voltage?
No. So we would add 1 and the volt and 2, 3.
That's what I mean.
Yeah. So again, we would treat those two as a single resistor together in series with R1. So it means our voltage here, 54.6.
I mean, just for like checking and stuff.
Yeah. So yeah, if I work that out by the calculation doing I times R, then I could add this one, and it should equal 100. Does that make sense? My computer has decided that it's got to shut down in 1 minute to do updates. So if you're watching this in the future, it's about to end. Sorry. Okay, so we've got our currents, we've got our voltages, we've got our resistance. So the last thing we need to work out then is power, right? So power in R1 will be, how am I going to work that one out? Voltage times current. And what voltage will I use? The volt drop across that resistor, 45.5.